Hello everyone, welcome to Unit 5, Lesson 14, Notes on Stoichiometry. By the end of this, you should be able to answer the guiding question, how can you utilize dimensional analysis and BCA tables to solve stoichiometric calculations for a variety of chemical reactions? The goal for this is that we are going to combine the materials from Lessons 12 and 13, where we looked at the mole ratio and BCA tables, and the material that was on the previous quiz, where we looked at how can we use conversions for grams, liters, and particles and change them to and from moles. So we're kind of mixing them all together, and that's going to be the goal. So we're going to first look at this do now together, and then the goal is though that you do the do now first and then you follow up with the video. And then we will dive into notes. So from the do now, we have a reaction that the main substance found in human bones, calcium phosphate, as given. And we're going to solve A first. How many moles of calcium phosphate can you make using 6 moles of calcium chloride? So we're going to use a BCA table for this. So I'm going to write my balanced chemical equation. And we know it's balanced partly because it's got coefficients and we're just trusting that it's balanced. But you can always check. Okay. So we have this equation, and so we're going to set up our BCA table. We see we have 6 moles of calcium chloride, and we want to find the moles of calcium phosphate. So we are given 6 moles of calcium, and I think there's something weird up with my pen, but we're going to keep running with it. Okay, so we have this for our roadmap. Oops, I missed the units, moles. So we're going to set up our BCA table, and because we're going moles to moles, we know that that's all we have to do for this one, is set up the BCA table. As a reminder, there are no products before our reaction begins, and we assume for right now that there are no reactants after we finish. Our next step is to plug in our given, which was 6 moles of calcium chloride. I'm going to move that a little bit over more. So we have our given in there, and now we're going to bring down our coefficients for the change. So the 3, and because it's a reactant, it's a minus sign. So minus 2 times something. Products are positive because we're making them. And then we're going to use our given box here and put an X here, and we're going to solve for our parentheses by solving for X in the calcium chloride. So we use this because X, or the parentheses, is the only thing we don't know in this column. So 6 minus 3X has to equal 0. Solving for X, we see that X is equal to 2. So in my parentheses, we have 2. After solving for the parentheses, we can fill in the rest of the unknown values in the table. So something minus 2 times 2, that has to be 4 to make that equal to 0. 0 plus 1 times 2 is 2. 0 plus 6 times 2 is 12. Looking back at what I was asked for moles of calcium phosphate, and that would be here. So my answer is 2 moles of calcium phosphate. Okay. Now trying B, you should pause this video and try it yourself, and then continue forward. You can pause at any point if you get stuck where you're supposed to go. So looking at what we are given for B, we are given 111 grams of calcium chloride, and it asks us to find moles of calcium phosphate. Now, Now we see we are starting with 111 grams of calcium chloride. And we want to end up with moles of calcium phosphate. Now we're used to going from grams to moles of the same substance, but not when we have two different things, because these two will have very different molar masses. So I cannot use a molar mass directly. I do know that I can go from grams of calcium chloride to moles of calcium chloride, because that is a molar mass conversion. That is one that we are used to from our previous segment. And we just looked at how we can change between moles of two different things. So we know this one would be a molar mass conversion, and that this last one would be either our BCA table or we need to use the mole ratio. You guys should soon be getting one of these. I have them printed if you want to swing by and grab one, or I'll hand them out during our next class meeting face-to-face. This is a full mole map for stoichiometry. We have looked at just one side of this, and so they're mirrored on both sides to be the same. What we have added is this in the middle, and we're connecting it all together. So this in the middle is where we would use the BCA table, and you are allowed to write this on your version of the handout, which uses the mole ratio. If you're doing dimensional analysis, it's actually written here for you as well. Notice what we're given is on the left and what we want is on the right. So if I look back at my stuff, I'm given calcium chloride. So I'm starting here with grams of calcium chloride. And the only thing I can go to is moles of calcium chloride. Right? But I want moles of something else. So what I want to go to is here. And I want that something else to be the calcium phosphate. I could go to the mass or volume or anything else on the far right side, but it specifically wants us to go to moles of what we want, something different, something new. Okay? So then I would use a BCA table or straight dimensional analysis to go from moles that we were given to moles that we want. So this is what we are doing in our calculation, and that is the roadmap we wrote down here. So now I see I have 2 steps. My first step is to convert using molar mass. So I'm going to do that. So 111 grams of calcium chloride, and I want to change that into moles of calcium chloride. Doing the disco, I'm going to take the grams and drag it diagonally so that it cancels out. And the mole to mass or molar mass says that 1 mole has a specific mass from the periodic table. Adding the masses of calcium and 2 chlorines up, we get 110.98. And now I'm ready to do my math. My grams cancel, and I'm left with just moles. So I'm going to do 111 divided by 110.18, and I get 1.00 moles of calcium chloride. It is important because we are talking about 2 different substances, but also up to 4 different substances, to label your numbers with a chemical formula so you know what it belongs to and where you will use it next. So this is our first step. Our second step, so we are here. Our second step is to now use a BCA table to find the moles of calcium phosphate. So when I'm setting up a BCA table, I start by writing my balanced chemical equation. And making sure I write down my coefficients and subscripts correctly. I guess the letters as well, because that was special. And then I write my BCA, so BCA. So I've got my table set up, reminding ourselves that there are no products before, and we assume no reactants after. That will change, but for right now, we're keeping it simple. Then we plug in our given. We were given a specific number of calcium chloride. Only moles go in the BCA table, so I need moles of what I was given, which was this. So it is going to go here, because that's the only blank spot I can fill in for calcium chloride. And then once I've got my given in, I'm going to bring down my coefficients for the change row. And then I use my given column to figure out my parentheses. So this is going to be my x temporarily. So I have 1 minus 3x is equal to 0. Solving for x is equal to 0.33, or 1/3. So I'm going to switch this out, and all of my parentheses are equal because this is the number of times I can run this reaction. Once I have the parentheses done, remember we can now backfill the rest of these. So 0. Using an unrounded number, that's 67. And this one would be 2. Okay, looking back at what I was asked for, it wanted me to find moles of calcium phosphate. Well, here's calcium phosphate, so my moles I make is this. So I'm going to label it special. And that's all I have to do for this. I could go further and change this to grams or to particles or something, but it only asked us for moles, so we stop at moles right up here. Now this is how we would do this with the BCA table. What about using dimensional analysis? We're going to look at that in the notes. So we're going to look at how we can use BCA tables and dimensional analysis within the notes. So the thing about BCA tables is only moles can be used in a BCA table. That's why we don't have to write our units next to it. But we are often, as shown in the do now, given and or asked for grams of a substance instead of moles. This is because there's no easy way to measure or count out the moles because it's a counting unit, but the particles are super tiny. So we can use, though, a scale to measure the mass and then use known values of molar mass to convert to moles. So that way we can then compare ratios of reactants and products in a chemical reaction. That is where the BCA table comes in. So when we work on stoichiometric problems, grams have to be converted to moles first, and then we can convert moles back to grams. So we can't go grams to grams directly. We always have to go to moles first. There are a series of steps here to help us do that. So we convert grams into moles, and this could be liters or particles as well. And then we set up our BCA table and fill it in, right? Set up and complete the BCA table. And this gives us the moles of what we were asked for. So that's the goal, is to figure out the moles that we were asked for. And then we can convert moles into grams using that molar mass of the new thing we're asked. Okay. This whole process is stoich, and I'm going to show you with the BCA table first, and then we will come and look at it with straight dimensional analysis and talk about the pros and cons of both. Okay, so for this one, we are looking at the BCA table. I will redo this problem for dimensional analysis. So how many grams of solid calcium phosphate can be made when 25 grams of dissolved calcium chloride, so look, that's a number given. So calcium chloride is given, are combined with excess aqueous sodium phosphate. So it is asking me for grams of calcium phosphate. So this is what I want, is calcium phosphate. Okay, and I'm given grams of each. So I'm given 25 grams of calcium chloride, and eventually I want to be at grams of calcium phosphate. Okay, so then jumping to, or looking at our mole map, our stoichiometry map, we are given grams. So we are given grams of calcium chloride, and we want to find grams of calcium phosphate. So this map connects our two destinations. If we follow the only path the arrow can go, we're going to use molar mass to find moles of what we were given, which is calcium chloride. I can keep following that arrow. Notice the arrows only go one direction, to moles of what I wanted, which is the new substance, calcium phosphate. And I keep following to get to this path. So I'm going to take this road up here to get to my grams of calcium phosphate. So this is my road map. So that tells me I have 1, 2, 3 steps, where the first step is going to use molar mass. My third step will also use the molar mass, but of the new substance. And then to go from moles to moles, in this case, we're going to use the BCA table. Okay, and that'll be our second step. So I'm going to rewrite that here. Okay, so I have 1, 2, 3 calculations. So here we go. First one is to take 25 grams of calcium chloride, and we're going to change that into, moles. So that's what we already said, grams of calcium chloride to moles. And I'm going to disco to get my grams on the bottom. Now this is the mole to mass ratio, or molar mass. So for every 1 mole of calcium chloride, we calculated this earlier, there's 110.98 grams. Grams cancel. So then I'm going to, into my calculator, put 25 divided by 110.98. And I get 0.23 moles of calcium chloride. Okay. So I've done my first step. Now I'm going to do my second step, which is the BCA table. So BCA, writing it underneath the reaction to help set everything up. No products before. Assume no reactants after until we update. And then I fill in my given. I am given calcium chloride, so this is going to go in the before because it's a reactant. I don't have any reactants after. So 0.23 before. Now I'm going to bring down my coefficients. Okay. And then I'm going to, in my given column, substitute the parentheses for x and then solve for x. And so solving for x, x is equal to 0.075 moles, but that's going to be what goes in my parentheses. All the numbers in here are moles. Oops. 0.075. After finishing my parentheses, we now can fill in all the extra blanks. So this becomes 0.15, 0.075, and then that last one I should actually do the math and not in my head. This is 0.45. Okay. So now we've got all these numbers. We go back to what we were asked for, which we were going from moles of calcium chloride to moles of calcium phosphate. So this is what we need from this table for step 2. But we have one more step. So we're going to use this answer in our next step. So our third and final step is to take this 0.75 moles of what? Calcium phosphate that we wanted. And we're going to change that into grams. So we are going to set up our T-chart. We've got our roadmap above. Change that into grams. drag moles diagonal so they cancel. And then we have to calculate the molar mass. So 3 times 40.08 plus 2 times 30.97 plus 8 times 16 is 310.18. And that's the mass for every 1 mole, molar mass. Okay, so it's from the periodic table for calcium phosphate. So then the moles cancel. We multiply 0.75 times 310.18. And we get 23 grams. And label it with the substance. Okay. Now BCA tables, yes, looks a lot longer. Remember, one of the benefits for the BCA table is it gives you a lot of values all at once. So if the question is asking you for more than just one value, you get all of them at once and don't have to do a whole bunch of separate calculations. Okay? The other reason that the BCA table is helpful is because it reduces the amount of mole ratio mistakes that you will make. And I will show you what those could be in the next problem. So we are going to redo this problem, but this time we are going to look at it for dimensional analysis. Okay, so same question. We want to find grams of calcium phosphate, and we are given 25 grams of calcium chloride. So using our map, we have to go mass, 2 moles, 2 moles, to mass. Oop. So then first moles of calcium chloride, then 2 moles of calcium phosphate. Then we can go to grams. Now when we do our train tracks, this tells us that on the top, we're going to have all of this, and that we will have lines for these. So that's what I'm going to set up, is 25 grams. Dimensional analysis is great when it's only asking you for one thing. We don't see any other problems after this that asks us for sodium phosphate or sodium chloride, so we don't have to worry about it. So this is helpful for that. So looking at our map, we first go to moles of calcium chloride, then to moles of calcium phosphate. Then we can go to grams of calcium phosphate. Disco, so I'm going to drag my grams diagonal. So it's always the top left to the bottom right, and only the next one over. Moles over here. And notice we have to label with our substances because we have the 2 same units here. We wouldn't be able to tell the difference without those chemical labels. Okay? Now we're ready to fill in our numbers. A gram to mole is the molar mass, so it's always 1 mole to the mass from the periodic table, so 110.98. We calculated that one already. And I'm going to do the last one too, because we know 1 mole, and we did this one in the last problem, or last slide, 310.18. This one is a mole ratio. We've looked at this already. We're just now adding it into the middle of a very long calculation, or train track. This comes from the balanced chemical equation. Above. So this is our coefficients. So I look at my balanced reaction and I see that there is no coefficient for calcium phosphate, so that is a 1. And the coefficient is a 3 here. Okay. So only in a mole ratio can these two be different than 1, or if we're using molarity, but that's super different and it's given to you. Now we're ready to do the math. Cancel what cancels out. And you are going to multiply across the top and divide by the bottom. So 25 divided by 110.98 equals, and you should get 0.23 divided by 3, 0.075 times 310.18. And you should still get 23, and it says 23.29 and some blah, blah, blah. But 2 sig figs, 23 grams of calcium phosphate. Okay, so it gave you the same answer as this slide. So different ways to show your work. This way is useful if you're only asked for one thing and only given one thing. So very simple stoichiometry. This works and it is fast. There are some common errors though that could happen. A lot of the times I will see you guys put a 3 here because it's got a 3 in this reaction. Do not do that. Molar mass is always 1 mole to the periodic table molar mass. That brings me to another mistake. A lot of the times I will see you guys multiply this by 3. No, molar mass is independent of the balanced chemical equation. It is solely based off the chemical formula. Okay, so that's the common substitutions I see, is putting the mole ratio in the wrong spot and multiplying by your coefficients in the wrong spot. The coefficients only belong in the mole to mole ratio. Okay, nowhere else will you use them besides the BCA table, but that's the same thing. Okay, unless I specify, you can choose which one you do. Okay, so that concludes the notes. You are to work on Unit 5, Lesson 14, Mole Tunnel. You can use this as you work to help you guys map it out if you don't have a paper copy. Those will be coming soon. When you finish, you can move on to Lesson 15. Please be aware that Lesson 15, like Lesson 14 stops here, Lesson 15 starts here. This one is a little extra tricky, so be careful with it. It will probably be done together, so leave some space for it. This one is also tricky. And for 4, you will want to use a BCA table, and this should actually be page 75. I forgot to update that. Okay, so that concludes the notes. Thank you guys for tuning in. Let me know if you have any questions.